Hello everyone, welcome to Robotics Laboratory 1. In this lab, we will be getting familiar with the ABB IR1200 robot that we have in our lab. Basically, we will be using Robot Studio to do all the practicals in this lab, but all of you are welcome to come to our lab and use the robots once the situation gets better. So let's start with the first session. So the objective for today is we will learn something about the safety conditions in the robot before we start to use the robot in the lab, and we will understand something about the robot coordinate systems. Together with that, we will also learn how to use the robot using the FlexPendant, or also called T-pendant, and then you will also learn how to jog the robot and write a basic program. So to introduce the robot arms, I think all of you are familiar with the robot arms. They are also called robot manipulators, and they are mostly used in the industries for a long time, and they are very useful in industry because they can carry out the pick and place tasks and every other task more easily and more efficiently than the human. And the robot that we have from ABB is called 6-axis robot, that is also very famous in the industries. If you see this diagram, we can see in what field in industry they are mostly used, the industrial robots. Okay, let's briefly discuss about the types of industrial robots. So the first type you see is the 6-axis articulate robot. This is called articulate robot because it has only rotary joints. That means all the joints that it has can rotate around one axis, and it's called 6-axis articulate robot because it can rotate through 6 axes. So the axes are, first one is around here, first, second, third, fourth, fifth, and the sixth one is at the end of the robot. That's why it's called 6-axis articulate robot. The second type you can see is delta robot. The delta robot is also called spider robots. They are unique when you see, because they have 3 motors mounted around here, which moves the end effector that is connected around here. So they are useful in pick and place or assembly operations. Also it can also be used in 3D printing or CNC as well. So the other type of industrial robot is Cartesian robot. It is called Cartesian robot because the robot can only move in Cartesian directions. By that I mean it can only move in X, Y and Z direction. Let's see, if this robot can move in this direction, let's say this is X and Y. This particular model shown here will not move in Y direction, but it can move only in X and Z direction. But there are some robots that can move also in Y direction as well. So these are also called Cartesian robot because they can only move in X, Y and Z linear motions. And the other type of very famous robot that is used in industry is SCARA robot. They are one of the fastest robot to operate in industry, and they are also very famous in the industry. They are very good when you have to perform some tasks of pick and place, let's say, where you have to move some object from one plane to another plane. For example, if some object is moving in a conveyor and then you have to pick it up and place it somewhere else, then these robots are very useful, and they are actually very accurate and very fast. That's why they are quite famous in industry. So let's go around the safety awareness before using the lab. So when you come back to the lab once the situation is better, so you have to keep these things in mind. The first thing is the maximum speed that we allow you to use is only 20%, and whenever you want to execute some program you have to get permission from the staff. And always make sure you know where the emergency stop is, and once the robot is uncontrollable you have to push the emergency stop and call the laboratory staff to help. So let's see what are the safety solutions that are provided by ABB. You can see this button here, it's an emergency stop button. You can find this button in the controller of ABB robot. So if something goes wrong, you just have to press this button and the robot will stop everything. Apart from that, we also have a emergency stop in FlexPendant as well. If something goes wrong, you can press that button as well. And there are some modes that you can use the robot in. So if you see, there is a key that is used to switch between the modes. The mode shown by the cursor right now is an auto mode. When you write all the program and then you want to operate the robot in automatic mode, you will have to switch the key to that direction. And the second mode is manual mode for teaching. So this is basically when we are using the robot to teach the points, we use the robot in this mode and we teach the point. And the third mode is manual full speed mode. This is basically we use when we want to test whether our program runs nicely or not, correctly or not. And you have to be careful, it runs in 100% speed, so we have to keep the emergency stop within our reach. Anyway, this configuration also differs from controller to controller. In the controller that we have in our lab, we don't have the third mode of manual full speed mode. We just have auto mode and the manual mode. So when we are teaching some program to the robot, we will use the manual mode, and then once we are sure everything works well, we will run the program in auto mode. So even while we are in the lab, we will not use 100% speed even in the auto mode. So let's talk about the enabling device. We will talk about this FlexPendant in next slide, but let's see how we can enable the device. So this is a FlexPendant, and then to enable the device, or when we want to jog the robot or move the robot using this device, we have to enable the motors. So to enable the motor, we have to use the grip here. It's also called dead man's grip. So there is an enabling device around here. So it has 3 modes. The first mode is the default one. When it is in the first mode, even if we move the joystick or press any buttons, it will not move the robot. And then we have to press in one step. If we press it slightly, it goes to the next step, the enabling device. So in the second stage, we can see the motor will be on. We will see the status on the FlexPendant itself, and when the motors are on, then only we can jog the robot. And on the third position, if we press it further, again it will disable all the motors. So that means we can only move the robot when we place the dead man's grip in the second position. Also for this, we cannot demonstrate it through online. So whenever the situation gets better and you come back to our lab, you can see how we can enable the robot using this device. Okay, so this is the robot manipulator that we have in our lab. So this robot arm or robot manipulator only comes with the manipulator, and what we have added here, this portion that has the vacuum cup which is used to pick up the blocks, is called end effector. So anything above this part is called manipulator, and everything that we add to the manipulator for the tasks is called end effector. So end effector will determine what work our robot arm is going to do. So it can be just the pick and place, so we just use vacuum cup, or we can add some welding machine in the end effector, so it can perform the welding operation, or it can have multiple other operations. It depends upon the end effector. So like I already told you, this robot that we have in our lab is called 6-axis robot because it can move in 6 axis. That means it has 6 joints through which it can move. So the first axis, you see axis 1, and that is axis 2, axis 3, axis 4, 5 and 6 respectively. Okay, let's see about the coordinate system. So every robot, they come with the coordinate system of their own. If you see at this, in this picture, there is a Cartesian coordinate x, y, z at the base of the robot. So this coordinate system is called robot coordinate system. And also for the tool, we can add any kind of end effector as per our requirement, like I told you. So the end effector will have their own coordinate system, and that coordinate system we called it as tool coordinate system. Okay. Similarly, when we have multiple robots operating in one single system, then we cannot rely on only one coordinate system, let's say only one robot coordinate system or something. So we just mark one coordinate system as a reference and call it world coordinate system. And so when we have any tasks to do for the robot, so we will map all the points based on the world coordinate system, and then we will transform the coordinate system into the robot coordinate system, and then we will transform it further to the tasks, further to do the tasks. Okay, so this is the controller that sends the signal to the robot hardware when we put some command. Let's say we want to move our robot in X direction, then our teach pendant will send that command to the controller, and controller will relay that command to the robot. So in the controller, you see there is one switch here. This switch is used to turn on and off. So when it is in vertical direction, it's on, and when it is in horizontal direction, it's off. And together with that, like I told you, there is a emergency stop. If something goes wrong, if the robot is uncontrollable, we will just press the emergency stop. And this is the mode selection key. So for, like I told you already, there is only auto mode and the manual mode. So whenever we want to move the robot using the touch pendant, we will keep it in manual mode. And there is also one button to enable the robots when enable the robot joints when we switch to auto mode. So you can see there is also I/O interfaces. The I/O interfaces are generally used when we attach any end effector to the robot, and that end effector can be controlled by our program for digital input output. So for example, right now in our robot, you can, I think you have observed, we have vacuum cup. So whenever the robot arm reaches to one block. So to pick that block, we have to turn on the vacuum suction cup. So that vacuum suction is triggered by the input output that is mapped from this hardware. Okay, now let's discuss about FlexPendant. So this is the FlexPendant that comes with our robot, ABB robot. Generally, every commercial robot manufacturer, they have their own FlexPendant or teach pendant. The model might be different, but overall the functions will be same, somewhat the same, but it depends upon the manufacturer to manufacturer. So let's see, in ABB teach pendant we have a Windows button here, so where we can get access to multiple functions, and then there is also a status bar which shows which mode the robot is currently on. It will also show the status of the motors, and together with that it will also show the speed the robot is operating on. And then there is also QuickSet menu, from where we can select the speed of the robot and further other features. And then there are some buttons that we can use. So this set of 4 buttons are for our use. Like we can define the function of these buttons by ourselves. So let's say, for example, we design our gripper, and then we want our robot to do run a function where it will change from one gripper to another gripper. So we can define that function under one key. So after pressing the key, we can make it do some tasks as we want. And the red thing that you see here is emergency stop, like I told you, and the thing near here is enabling device. Together with those 4 buttons, there are also few jogging buttons which we will discuss in the practical part with Robot Studio. We will see how we can use. And then there are also 4 set of program execution buttons. So if we want to run a certain command that we wrote for the robot, we can use these buttons, and then also we can execute whole set of commands and stop them. And then there is also USB port. If you want to upload some program or update the firmware of the teach pendant, we can use the USB port for that. Okay, so this is the QuickSet menu that I told you previously. So basically when we use the QuickSet menu, we will see these things, but when we are using in auto mode, these things are already disabled. But just what you need to know is we will override the speed of the robot using this menu. So you have to touch on the menu, and then you will see whole menu, and then you have to select the second option where we can select the speed. So just to remind you, we can only use 20% speed when we are in the lab. So I will just tell you something about jogging the robot here, and then we will also see the video where I will show you how to jog the robot using the FlexPendant. So before jogging the robot, we have to set the robot in manual operation. So to set the manual operation mode, we will use the key and then set it to manual mode, and then we have to enable the enabling device or dead man's grip. So it should be in the second position, so that we will see the status like motor on here. So when we see the motor on, then we can jog the robot or move the robot using the teach pendant. So this is the window button. So when you click the window button, these are the options that you see. So if we select window button and go to jogging, we will see a window something like this. So this window has lots of information in it, and together with this information it also shows how the joystick works in this mode. So that means right now if we move the joystick in vertical position, it will move the robot in X direction, and in horizontal direction it will move in Y, and if we twist the joystick it will move the robot in Z direction. So there are few jogging modes that are available. So if you see here, if we click this button here, we can switch either from linear mode or reorient mode. So the linear mode is the Cartesian mode, to move the robot in X, Y, Z direction, and the reorient mode is actually to change the orientation of the end effector. Sometimes, okay, for example, let's see, when we are welding something, our robot tip or the tip of the end effector might not reach the place where we want to do the welding. So in those cases we want to reorient such that it can comfortably weld the surface that we want to weld. And the second button is to select the jogging in two modes, like axis mode. So group 1 axis will consist of 1, 2, 3. That means we can only move axis 1, axis 2 and axis 3 of the robot. So we already know our robot has 6 axes. So when we select group 1, then our joystick here can only move the 3 axes of the robot, and if we press this button again, then we will switch to group 2. That means we can only use the axis 4, 5 and 6. Together with that, we also have a incremental jogging. So let's say we are performing the pick and place of the block. So whenever we want to teach the point to the robot, we want to be more as precise as we can. So when we jog it normally, the robot might drift a bit more than we expect. So when we want to be more precise, or let's say when we are very close to the block, we want our robot to move very slowly so that we can properly place it around the center or wherever we want. So at that time we will activate the incremental jogging using this button. So what does this button does is, when this button is active, or when incremental jogging is active, it will move the robot in it will shift the robot by very small distance. We can also define the distance by which it wants to shift. It can be in terms of some millimeter. Let's say if we move the joystick to vertical X, then it will only move 2 millimeter in X direction, or we can set the incremental value for that. Okay, so this is how we will jog by axis. So to jog by axis, we can use the jog by axis button, and then we will see the status something like this. You can see here right now it is showing 1, 2, 3, 1 or 3. So that means we can only select the axis 1, 2, 3. So that means we can only use the axis, this axis 1, axis 2 and axis 3. And to select other 3 axes, we have to again press that button. So we will select axis 4 to 6. So when axis 4 to 6 is selected, we can only move axis 4, 5 and 6 with the help of the joystick. And for the moving the robot in Cartesian coordinate, we have to use the Cartesian or linear or reorient button you see here. So when we select that button, then you can see we will see the Cartesian image in the teach pendant around here, and for reorient also we will use the same key. So that's the theory part. Now we will move to another video and see how we can jog the ABB robot that we have in the lab, and we will practice how to move the robot along every axis 1 to 6, and also in Cartesian path x, y and z axis.